Okay, so 2019 question 4 from English paper. Show that cos 2 theta is equal to 1 minus 2 sine squared theta. So that there's a trigonometric identity, and if you open your log tables on page 14, you'll see all the trigonometric identities, and the one you need is the one for cos 2 theta, in this case cos 2a. And it tells you that cos 2 theta, that's the same as cos squared theta minus sine squared theta. And you know from page 13 that cos squared a plus sine squared a is equal to 1. So cos squared theta plus sine squared theta is equal to 1. So work out what a cos squared is equal to on its own. It's going to be equal to 1 minus sine squared. And that there is what you substitute in for cos squared. You get 1 minus sine squared theta minus sine squared theta. That gives you 1 minus 2 sine squared theta. So very straightforward part A. Part B, it said find the cosine of the acute angle between two diagonals of a cube. Now, because it's a cube, you have both sides are equal. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so there's the face of the cube. Okay, so imagine that, for instance, is the top face of that cube. So we can work out the diagonal using Pythagoras' theorem. So we'll just call it y, for example. So x squared plus x squared is equal to y squared. That means 2x squared is equal to y squared, which means y would be equal to the square root of 2x squared. So that's what the diagonal is, the square root of 2x squared, or if you want to be really accurate about it, it's the square root of 2 by x. Now, that diagonal, the diagonal of the face is going to be that line there. Okay, the diagonal of the face. And the shape that we're dealing with here in this question. Okay, but I didn't really say what you're trying to do here. You're trying to find the cosine of this angle here. So we're dealing with this shape here first of all, and then we've got to look at the triangles inside. But that shape is shaped. This is actually something like this. A rectangle. Now, if you've ever cut a block of wood up, you'd recognise that it's if you had a block of wood and you just sliced it, you're going to get this rectangular shape when you cut it at an angle. So if you were to slice that right down through the middle along that pink line down here, you'd end up with this rectangular face facing outwards. And what we have to do now, that there is still x, so that there would be x, that would be x. And this line here, as we've said already, is the square root of 2 by x. So what we need to do using Pythagoras' theorem is work out the distance from here to here. Okay, we need to find out the length of this side, and then it's going to be the same as the length of this side. So Pythagoras' theorem, you can see here, you can create this right angle triangle, and that triangle that I create there is possible because I know that these diagonals are bisecting each other, but they're meeting at the halfway point of x. So here to here is x, here to here is x over 2. And if here to here is the square root of 2 times x, here to here is the halfway point as well. So we've got the square root of 2 by x all over 2. So using Pythagoras' theorem here, I can work out the length of, again I'll call that, better, I'll call it w. So w squared is equal to x over 2 to be squared plus the square root of 2 by x over 2 to the squared. So w squared is equal to x squared over 4 plus this is 2x squared over 4. So w squared is equal to 3x squared over 4, which means w is equal to the square root of 3x over 2. That's what w is. So we've got this triangle here. Got this angle, we'll call it A, for example. We know that the distance from here to here is now the square root of 3 times x over 2, and this here is the same distance, square root of 3 times x over 2. And we know still that the length here is the same as the length here, as it always was, it's x. So, using the cosine rule, we're going to be able to work out the angle A. Here are right angles, page 16. Here's your cosine rule. So you've got, in our case, it's our little a is going to be x and our big A is A. Okay, just the way it worked out with the question so far. So we have x squared equals b squared plus c squared minus 2bc cos A. So substitute in everything that we have. So for x it's still x squared. B squared is the square root of 3 by x over 2. That's going to be squared. Plus c squared, which is the same thing. So square root of 3 x over 2 to be squared. Minus, I'm running out of space here, so I'll just put it down to here. So don't run out of space there, but I'll keep going. Minus 2 times this, square root of 3x over 2 by c, which is the same thing, square root of 3x over 2 by the cos of right. So some of this is going to tidy up for me nicely. So just writing with the markers is a little bit thicker than writing with the pen, so I'm just going to have to go outside the line here. So x squared equals, now this squared is 3x squared over 4. This squared is the same thing, 3x squared over 4. We've got to square this again, so it's minus 2 times this by this is going to give us 3x squared over 4. All by the cos of A. So 3x squared plus 3x squared is actually 6x squared. So you've got 6x squared over 4 minus 2 by 3 is minus 6x squared over 4 by the cos of A. We've got to solve for A here. Or we've got to find out what the cos of A is. We've got to bring everything over here. Now, 6 over 4 is the same as 3 over 2. So x squared minus, so I'm going to just keep everything in 4s actually. So x squared is the same as 4x squared over 4. So 4x squared over 4 minus 6x squared over 4 is going to give you minus 2x squared over 4. So when this comes over, you can subtract it away from that, you're left with this, and it's equal to minus 6x squared over 4 by cos A. That gets rid of your minus signs. Both sides are of the equation of minus, so you can just multiply by minus 1 across and everything becomes positive. Now, 2x squared over 4, this 4 is divided by over here, it comes across with that multiplied. This 6x squared is multiplied over here, comes over here, multiplied by. That's all going to be equal to cos A. That stuff cancels for you. The 4's cancel, the x squares cancel, and you're left with 2 over 6 equal to cos A, which means 1 over 3 is equal to cos A. So was it done, yeah. Not sure what the marks were for that, but I imagine this part here was 10 maybe, and this was 15. So again, it's not proportionate. This could have been 5, this could have been 20. A lot more work went into getting the marks over here to get them over there.